Plastics and Polymers is a section of organic chemistry that deals largely with macromolecules, which are molecules that consist of a large number of atoms. And specifically a polymer is a large molecule composed of smaller monomer units that are covalently bonded to each other in a repeating pattern, where a monomer is a small organic molecule that can be covalently bonded to another in a repeating pattern, and a repeating unit is the smallest unit that can be repeated to create a polymer. So the way that this works is that you would start with a monomer, which, as the definition states, is an organic molecule in itself, but what makes it special or unique is the fact that it can become a repeating unit. So here we have a monomer called ethene, which is 2 carbons double bonded to each other with 4 hydrogens, but that can become a repeating unit by breaking the double bond between those 2 carbons. When that happens, each carbon is now looking to form another bond, and so these repeating units can attach themselves to each other to form a very, very long chain, also referred to as a macromolecule. Now, because we often do not want to or are not able to write out how many carbons exactly make up this macromolecule, we often write it in its polymer form, where we show the repeating unit in brackets with a number n, which is an integer number that says how many repeating units there are. So once again, with the monomer ethene, we can, by breaking that double bond, create a repeating unit that can repeat itself in number of times, which creates a polymer called polythene. The reaction that is required for this is called polymerization. There are a number of important monomers to know. The first one is vinyl chloride. So the monomer that contains a carbon-carbon double bond and 3 hydrogens and 1 other atom or group of atoms is referred to as vinyl. So vinyl chloride says that that other atom is a chlorine atom. And so when this monomer unit is converted into a repeating unit and therefore a polymer, vinyl chloride becomes polyvinyl chloride, or PVC, which is the plastic that we use in most shopping bags. Another example of a monomer is vinyl benzene, where here we have a benzene ring attached to that carbon, and when this is arranged into a polymer or a macromolecule, it becomes polystyrene. A third example is vinyl acetate, where we now have an acetate group of atoms attached to that vinyl molecule, which when repeated in a unit becomes polyvinyl acetate, or PVA. And the same goes for the monomer vinyl alcohol, which becomes polyvinyl alcohol. It is important to understand the difference between a monomer, which is the unit that can exist on its own, and a repeating unit, which just shows how these attach to each other. And then when they are placed in a bracket with an integer on the outside, that becomes the polymer that refers to how long that molecule is, by indicating how many of those repeating units are attached end to end. Polymerization is a chemical reaction in which monomers join to form polymers, and there are 2 types of polymerization reactions. First one being the simple addition polymerization, where very simply the double bonds on a monomer break, which allows bonds to form between the repeating units. So as an example here, we have the repeating unit that is obtained from the monomer vinyl chloride, that being 1-chloroethene, and when that double bond breaks, it forms, or it allows a radical to form on either side of the carbon, which allows those carbons to look for bonds, which then allows those carbons to attach to each other in an ever-growing chain that goes on to form a polymer. So the addition polymerization starts out with the double bonds on the monomer breaking, which allows it to form these repeating units that can then attach to each other and go on to form the polymer polythene. The second type of polymerization reaction is the condensation polymerization. And this example here shows that there are 2 steps to this process. The first step being the alcohol combining with a carboxylic acid in the process we know to be esterification, and specifically this being ethane 1,2-diol combining with ethanedioic acid. That goes on to form what is called a dimer, which is essentially a molecule that consists of two monomers and water. These two monomers can then combine with themselves in a very similar way to the addition polymerization, the difference here being that as they combine, there's a hydroxyl group and a hydrogen ion that is eliminated at each combination, and as a result we form water, or water is condensed out of this polymerization reaction, and we have once again an ever-growing molecule. And in this case, what we can show here is we can show the repeating unit over here. We say that there are n number of this repeating unit in the polymer, and along with this polymer we are also going to form 2n molecules of water. This is the polymer polyester.